Hey, sixth graders, this is Munyan checking in. Today we're working on chapter 9, lesson 2, area of triangles, which we explored a little bit the last time by figuring out that if you draw an opposite triangle and attach it, you either get a parallelogram or a rectangle. So basically, you can use base and height to find the area of the rectangle and then divide it by 2, right? Okay, so we are going to explore that some more today. All right, so how we're thinking about how to use base and height to find the area of a rectangle. I mean a triangle. A triangle. We can use that same knowledge to find a missing dimension or to find a missing height. So height or base, basically. Find a missing height or base. Okay? This is a boring color. Let's change colors here. And let's make this a little smaller. All right, so here's our example here. It says, the Biosphere 2 complex in Tucson, Arizona, real place, researches Earth and its living systems. Sections of the building are interlocking triangles of the same size. Ooh, I bet that building is beautiful. Look at here. Interlocking triangles, or you can see smaller ones here. Okay, there are 2 triangles that are outlined in the photo. They have the same size and the same shape. Whoa, that means they are congruent. 5th grade word, if you remember it. So it says, draw the figure formed by the 2 triangles. I think this might be a little bit offset. I do think it's a parallelogram. Not by much, though. Trying to make these sides the same. Whew. How many small triangles make up the outlined parallelogram? How many small triangles make up each outlined triangle? Ooh, well, so the outline parallelogram. Can we count them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So each triangle, that would be half that amount, right? So each triangle has 9. 18 divided by 2 is 9. So now we are describing the relationship between the area of one outlined triangle and the area of the outlined parallelogram. Well, if there's half the number of triangles in half the parallelogram, then I'd say the area is also half, wouldn't you? So there's 9 triangles in here and 9 triangles in here and 18 in all. So that would mean that the area of the triangle is half the area of the parallelogram. Let's see here. What's this next question? Draw another parallelogram like the one in the photo, separated into 2 triangles. Describe the relationship between the area of one triangle and the parallelogram. All right. So another parallelogram. I guess I'll try to make it different. Would that change anything if I make my parallelogram bigger? I don't think so, right? other than that this line right here isn't straight. So this is half the parallelogram, and this is half the parallelogram. So each triangle is half of the parallelogram. That is why when we find the base times the height, or with a rectangle, the length times the width, if we divide that by 2, we get the area of the triangle that we're looking for. That's why it works. Let's look at the next page here. All right, so the concept here is this right here. This is the important deal. If we multiply the height times the base, we're actually figuring out a rectangle, okay? We're actually figuring out a rectangle. So that's why we divide by 2 in order to find just the triangle, or parallelogram, technically that one was. And here's that word congruent. Really important that you understand that that just means same shape and size, okay? I suggest you circle, highlight, star, in some way make it huge and easy to find there, okay? And this is just saying the same thing again. The base of a triangle can be any one of its sides. The height is the perpendicular distance from the base to the opposite vertex. Okay, so see the height, it has to make a 90-degree angle. Okay, so don't be tricked into thinking that this is the height. This is not the height. Okay, it has to be a straight up and down line. Okay, perpendicular, like a T, perpendicular to your base. So here we have let's see, we're going to find an actual area. And so they counted units this time, 1, 2, 3, 4. All right, so, and then 1, 2, 3, 4, 5, 6. 4 times 6 is 24. Divided that by 2 and got 12. Moving on. This one says find the area of the triangle. And so they just did 12.1 times 6.4, which was 77.44. Divided that by 2. Do we need a refresher on long division, perhaps? That's a possibility, right? So 2 into 38.72 once. Oh, so remember it's divide, multiply, subtract, bring down, repeat. So now I multiply. 1 times 2 is 2. Now I subtract 1. Now I bring down. Now I do the 2 into the 18. 2 times 9 is 18. Then 9 times 2 is 18. Subtract, bring down, 7. Now 2 into 7. Oh, let's not forget our decimal there. Let's see here. 2 goes into 7 3 times. 3 times 2 is 6. Subtract, bring down, 2. Now 2 goes into 12. That's 6 times. 6 times 2 is 12. Subtract, and we're zeroed out. All right, so that's where they get that. 38.72. All right, so if you need to write that down so you have a reminder of how long division works, you need to pause the video because I'm going to erase it. Okay? Erasing, so I need room for the next 2 problems. All right. Now, the first one is units. When you don't know the measurement, you just say units. So we have 1, 2, 3, 4, 5, 6. And then remember, find that square. You want to go straight up and down, not at a diagonal. 1, 2, 3. That's a 3. 3 times 6 is 18. So this is going to be 18 divided by 2, which is 9. So over here we write 9. square units, or 9 units squared. Then this one here, we have a base of 9 and a height of 7, so area equals 9 times 7 divided by 2. 9 times 7 is 63 divided by 2. This is not even, it's not going to go in evenly. So let's see what that is. 63. 2 times 3 is 6. 2 times 3 is 6. Subtract 0. Bring down the 3. 2 goes into 3 one time. 2, 1. Nothing to bring down. Okay, so we put a decimal and a 0. Okay, and we bring down the 0. Put the decimal here. 2 goes into 10 5 times. So this is 31.5. And what is our measurement? Feet. Feet squared. All right, let's try another one. This one is a missing dimension. Missing dimension. But remember, we have our formula. Area equals base times height divided by 2. So we're just going to plug it in. What's our area? 24. Excuse me. And what do we know? We know the height. So base times 6 divided by 2. All right. So we know that 6 divided by 2 equals 3. I'm going to move over here. 24 equals 3 times the base. What we do here is we divide both sides by 3. When we divide this by 3, 3 divided by 3 is 1. 1 times b is just b. So now we can move that 3 over to this side. What is 24 divided by 3? Well, if you're not sure, skip count off to the side. 3, 6, 9, 12, 15, 18, 21, 24. There's our number. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 equals B. All right, so over here, it's in meters, right? So we're going to say, and is it squared? No, only the area is squared. Dimensions, the base equals 8 meters. Not squared, because it's not the area, it's just the length of the base. All right. Let's take a look at this one. Here we have area equals base times height divided by 2. So the area is 72 yards squared. Okay, so 72 equals, and our base is 12, and we don't know the height. Divided by 2, okay? 12 divided by 2 is 2 times what is 12? 6. So now we have 72 equals 6 times the height. We can divide by 6 to cancel this out. 6 divided by 6 is 1. Then we're going to divide this side by 6. What is 72 divided by 6? Now remember, you have a multiplication chart both in your math notes and also in your journal. I don't know if you noticed that. Okay, so you can always go look. So I'm kind of giving you some time if you're scrambling a little bit. What is 72 divided by 6? Okay, so I'm not sure that goes evenly. Let's try it this way. Oops, I already made a mistake. Did you catch it? 6. 6 goes into 7 once. 1 times 6 is 6. 1, bring down the 2. Oh, it does go in evenly. 6 goes into 12. Oh, yes. Here's a trick, guys. 6 times 11 equals 66. Then you just need to add 6 more to see what 6 times 12 is, if you've forgotten, okay? 6 and 6 is 12, carry the 1. 6 and 1 is 7. Okay, so we have our missing side. The height equals 12 what? 12 yards. Is it squared? No, because it's just the length of the height. It's not the area of the triangle. Let's move on. Okay, so in this example, it says the front of a camping tent has the dimensions shown. How much material was used to make the front of the tent? Oh, a little pup tent. Haven't seen one of those in a while. So it's going to be 5 times 3, 5 times 3, and then you divide it by 2, which is 7.5. Could you do that one in your head? Let's take a look at this. 15 divided by 2. Well, I think of 15 as 14 plus 1. I know that half of 14 is 7. And I know that half of 1 is 0.5. So 7.5. Yeah, we could do that in our head. We don't have to do long division for that. We probably could have done that with the 72 as well. All right, so let's try some more. This one here is just units, and we're finding the area. 1, 2, 3, 4. 1, 2, 3. Remember, we're looking for the perpendicular or T line. We don't want this one. That's not the height. So this is 3 times 4 divided by 2. 12 divided by 2. The area is 6 units squared. Okay, here's another one. We've got 12 times 8. And then we'll divide that by 2. Do you know 12 times 8? If you don't, what is 11 times 8? Well, that's 88. And then if you don't know 12 times 8, just add 8 more to get 12 times 8. Okay? So let's see here. 8 and 8 is 16. 96, that's right. So we've got 96 divided by 2. What is that? Could we use our... Yeah, it might be easier to just do this. I'm not sure how you're feeling about it. 96 divided by 2, 4, 8. Remember, it's divide, multiply, subtract, bring down, repeat. So subtract 1, bring down. 2 goes into 16 8 times. So that's 48 what? Well, this measurement was feet, so this is feet squared. This always confuses people. Feet, it's an F and a T and you cross them both. So people just write the F and the T and cross them. All right, now we've got a decimal one here, so follow along. If you're a little rusty on multiplying decimals, you'll want to follow along here, okay? So we've got a base of 15.6 and a height of 11.25. So that's going to be 15 point... I'm writing my 6 backwards. That's silly. And 11... I should put that one on top. 11.25. Remember, you don't have to line up decimals when you're multiplying decimals, only when you're adding or subtracting. All right, so we've got 6 times 5 is 30. 6 times 2 is 12, 13, 14, 15. 6, 7, 6. Put a 0. Now we're on to this place value. 5 times 5 is 25. I'm going to erase some of this really quick so you can see. Okay, 25. 5 times 2 is 10, plus 2 is 12. 5 times 1 is 5, plus 1 is 6. 5 times 1 is 5. Now we're moving over 2 place values, so we put 2 zeros. And this is a 1, so 1 times 11.25. That's 5211. Add. Did you make sure that these were all straight? That will help you to add correctly. 5 and 5 is 10. 8, 10, 15, 12, 13, 14, 15, 6, 7, 1. And what about our decimal? Well, we have 1, 2, 3 numbers to the right of a decimal. So we are going to move our decimal over 1, 2, 3 places. Okay? And put it right there. So, do we need these zeros? Not really. We can just write this as 175 and 5/10. What's the measurement? Meters squared. Whew. Oh, were those decimals a little bit scary? You might be rusty right now. Try it once, check your work with a calculator online, and move on, because at some point in an earlier chapter in our grade 6 curriculum, we're going to actually practice multiplying decimals. But since we've skipped to here, if you need to use a calculator, I'm fine with that. Okay. Tayshawn designs uniquely shaped ceramic floor tiles. What is the base of the tiles shown? Let's find out. We've got a base unknown and a height of 6 and an area of 21 inches squared. So this is going to be 21 equals base times height, base times 6. We'll divide by 6. That cancels that out. Divide by 6. Does 6 go into 21 evenly? 6, 12, 18, 24. No. Okay, so let's do the long division. 6 into 21. Well, we know it goes 3 times. Subtract to 18. 18, 19, 20, 21. There is no more numbers to bring down. So I put a decimal and a 0. Bring down the 0, and 6 goes into 30 5 times. So that's 3.5. What's our measurement? Inches. And it's not squared because this is the base of this triangle for the tile, not the area. Let's try another one. Consuela made a triangular paper box as shown. What is the area of the top of the box? The area at the top. So we're just finding this one face, not the volume of the whole box, okay? We know the height. The height is 9 centimeters. So this is going to be, where can I put this? Maybe right here. We know the height and the base. We're just finding area. So area equals 9 times 10 divided by 2. So that's 90 divided by 2. 2 goes into 9 4 times. 8. Subtract, it's 1. Bring down the 0. 2 goes into 10 5 times. That's a 4, isn't it? So the area of the top of the box is 45, and it was in centimeters. Centimeters squared. All right. So this here says, how is the formula for the area of a triangle related to the formula for the area of the parallelogram? Well, they both start with a length times a width. A length times a width, or base times height. They both start with that. Okay, that's how they're related. A triangle also starts with a base times a height, right? Is there another page? Nope. Okay, you're on your own. Do as much of it as you can on your own. If you hit decimals and you're not comfortable with that multiplication yet, please use a calculator because we haven't gone through the chapter yet where I teach you that. Calculator equals okay on your Chromebook, okay? All right, have fun. Ask questions if you need to.